Now, we've talked about the 5 different types of factoring. You've got these listed somewhere already. You can jot them down again if you need to, but you don't have to if you've already got them. 5 types of factoring. We've started with our greatest monomial factor. Okay, that's where we look to see, is there something that I can pull out? Okay. Then we look at the difference of squares. Now, we haven't quite talked about the difference of squares yet, so let's talk about it for just a minute. All right, so go ahead and write difference of squares, and we're going to take a few notes on difference of squares. Okay, we good? Difference would indicate that you need to have what operation? Subtraction. So here's the thing, folks. If it's addition, it cannot be difference of squares. Okay? If it is addition, cannot be difference of squares.
Has to be subtraction.
Has to be subtraction. Now, difference of squares also has to be a binomial. Okay, it also has to be a binomial, which would mean that if it is a trinomial, it cannot be a difference of squares. If it's a binomial with addition, it can't be difference of squares. It's got to be a binomial. It's got to be subtraction. Okay? The other thing that you have to look for difference of squares is first and last term are perfect squares. Okay? So it's got to be a binomial. You've got to have subtraction. And the first and the last terms both have to be perfect squares. Okay? Everybody okay? Those are the 3 requirements in order for you to be able to use difference of squares. Okay? Now, so this is what a difference of squares might look like. So the first thing you got to ask yourself is it a binomial?
Yes.
Check. Is it subtraction?
Yes.
Check. Is it first and last term a perfect square? Perfect square?
Yes.
Yes. But you know why? This is even. Because I can pull out, how do I get an x squared? X and x. Right? How do I get an x to the 4th? X squared, x squared. How do I get an x to the 6th? X to the 3rd, x to the 3rd. Could I get an x to the 5th by multiplying the same 2 things together? No, it'd have to be 3 and 2, or 1 and 4. And those aren't the same numbers. Everybody agree? Okay. So, first one's a perfect square. Is the back one a perfect square?
Yes.
Yes. Do we need to make our list of perfect squares again, or can you all remember those?
We can remember.
You can remember them? Okay. Now, here's what you do to solve the difference of squares. What do you notice about the difference of squares? What's it missing? What's it missing? What's x squared minus 4 missing? It's missing that middle term, right? You got an A, you got a C. What are you missing?
B.
A B. So how do we get that middle term to fall away? How would we get it to not exist? What? They'd be the opposite of each other, right? They'd be the exact same number, but they'd be the opposite of each other. Everybody agree with that? Okay? So when you have a difference of squares, you simplify it by making 2 binomials. But now wait, how do two binomials get me a binomial?
Then do the opposite.
Well, how would I get my x squared?
X times X.
X times x. How would I get my 4?
2 times 2.
2 times 2. And then how do I get that middle term to go away?
Add.
One's positive, one's negative. And that's how you simplify a difference of squares. Sir. I know. Well, just because now it's officially called difference of squares. Okay? Everybody okay? All right, let's look at another one. You ready? Now, let's run through our checklist. Binomial? Yeah. Subtraction?
Yes.
Yeah. First and last term perfect squares?
No.
No. So, is there one of my other 4 things on that list I can do? Yes, what can I do? I can do a greatest monomial factor. What's my greatest monomial factor? 3. So you want to pull a 3 out? Alright, if I pull a 3 out, what am I left with inside?
X.
X squared
Minus 9.
minus 9. Oh, and now we what?
Now we do the difference of squares.
Now we have a difference of squares. So sometimes before you can get a difference of squares, there's other things that you have to do. Yes, ma'am.
Is this the only thing we're doing today, or can we do another one?
Okay. All right. Yeah. All right. So now I have a difference of squares. Everybody agree? Because I've still got a binomial. I still have subtraction. And now both of my first and last terms are perfect squares. So here's how we solve this problem. We keep our 3. But then this I have to split into 2 binomials. What is my first term of each binomial going to be?
X.
X. What's the back term of each binomial going to be?
3.
3. And what do I know about my signs? One's going to be positive, one's going to be negative. So it might not always start out where it looks like, oh, that's the difference of squares. Okay? There might be something you have to do to it first, and then you've still got to double check it. It's kind of like with our radicals. Remember with our radicals, how we had to get the denominator to not be a radical, but then we had to go back and double check and make sure we didn't leave any perfect squares underneath the radical in the numerator? Same concept. Once you pull out, you've got to still check. Okay? Everybody okay? So far so good? Everybody okay with difference of squares?
Yeah.
Questions about difference of squares? You've got to make sure it's a binomial, you got to make sure it's subtraction, and you got to make sure the first and last terms. Because what will happen is you will get one that looks like this. And you'll want to make it a difference of squares. Can it be a difference of squares?
No, because there's addition.
Which factor does it not meet?
Subtraction.
It's a subtraction. Okay? Everybody okay with that?
Yes, ma'am.
All right. Perfect. Let's move on then. Oh, here it is. Okay. All right, so that takes care of greatest monomial factor. We've done that one, right? Let's check it. Difference of squares.
Yes.
We good with that? Now we have a
Perfect square trinomial.
perfect square
Trinomial.
trinomial. Okay? And a
That's me. Or it's me. It's me. What? Is it emergency? Okay. She really needs to talk to you.
that's my toes.
Careful.
And breathe. Ryan Thompson.
Oh gosh.
Yeah, because you were like. Sit about that.
She sounds like a student.
David Stevens. B. And you want like two boys or a boy and a girl? They need to be able to function and read something. Anybody?
Me.
No, I need a girl. Anybody want to function and read something in front of the school?
Already doing something.
I'll do it.
You need to get Miss Bowling and Bonds Undying Gratitude. Alright, and one boy's on
This
it.
is gonna crack when I do it out loud.
Dude, I want to do it.
Alright, alright, Bowling will be in touch with you too soon. Okay, alright. Now, back to this. Perfect square trinomial. Okay, perfect square trinomial. By its name, it would indicate that this needs to be a what? Trinomial. It would also indicate
It has to be a perfect square.
that it has to be a perfect square. Okay? Except it's gonna the first and the now here's what you're gonna notice about this. You're gonna notice that you're gonna factor it like you normally would factor. But when you get done factoring and you got two binomials, they're going to be the exact same binomial. So when you factor a trinomial, you factor it just like you would if it was just a regular old trinomial. But what you notice when you get finished is that you're going to have ax plus c and ax plus c. They're going to be identical. Okay? So instead of writing it twice, okay, you just write it to where it's
The second title.
ax plus c squared. That's the only difference in 3 and 4 and 5. Because you do 3 just like you do 4 and 5. You look at your factors, you factor it like normal, okay? But once you get finished factoring it, you'll notice that you've got the exact same thing in both binomials. So instead of writing two separate binomials, you only write one binomial and put a squared up there. Does that make sense?
Yes.
So,
is this like an extra step to simplify it further?
yes. Like instead of it just being two separate ones, the next step is to write it as a squared and then it's even more simplified. Okay? So it's not really, you're not really having to learn anything new. You're just learning then how to take it to the next step of how to write it. Does that make sense? So the only thing really new you're learning today is what to do when you have a difference of squares and how to factor that. This you've already learned how to factor. Now we're just writing it a little bit different. Okay? Can you handle that?
Yes, ma'am.
Everybody good? And then 4 and 5 we've already talked about. So check on this one. Check and check. Everybody good? Oh, you just think we're done.
Oh, we're done.
Okay.
Oh, we're not done.
Oh, you just think we're done. Okay.
Oh, good.
No. We've already talked about how to do this. We've even already talked about how to pull this out.
Yes, ma'am.
And we've talked. Okay. Let's write this one down. We'll do it together. So go ahead and write this one down. Now, notice it says factor completely.
So that means it's gonna be more than one.
That means there could possibly be more than one step. You've always got to see, could I go a little further? So what, and you kind of go down the checklist. Is there anything that I can pull out of all of them? Yes, what is it? 5. So let's pull our 5 out. Can I pull any x's out? No, so this is going to make it what? X squared plus 6x plus 9. Alright, so let's see if we can, so then we need to, it's not a difference of squares, right? Okay, and so it's a regular trinomial, so we should check to see if it can factor. Right? So 9 becomes 1 and 9, 3 and 3. And I've got to add to get 6. Is there one of them that works?
3 and 3.
3 and 3. So then I'm going to have my 5 that's hanging out. And this can then factor into 2 binomials. What's my first term going to be? X and X. I also know they're both going to be pluses. And then I'm going to have what? 3 and 3.
So can we just write 5 parentheses x squared?
So now this, because I've written the same thing, is a what? Perfect square trinomial. So I can simplify this one more way.
And get 5x plus 3 squared.
That's as far as we can go.
Sir,
How do you know that, like, after you do it, you don't do, like, 5x plus 3, 5, extra 3 times?
because then you would just end up with what you started back with, and
Even if you do the other
It's really satisfying to see it.
it is, isn't it? Okay. Now, here's where you have to be careful. All right? Is when you break this down, when they're both positives, it's not a big deal. But if one of these is negatives, you got to look to see if it's going to be a difference of squares. Because if this one wouldn't, because x to the first is not a perfect square. Okay? And the 3 is not a perfect square. And it's not subtraction. But you've got to double check it. Does that make sense? Okay, and we'll look at one of those here in a minute. So this would be your final answer. Okay, that would be your final answer. Let's look at number 2. You ready? What do you want to do to it first?
Factor.
Factor? Well, that's kind of what we're doing already. Is there a greatest monomial factor?
No.
Is there anything I can pull out?
No.
No. So then I should probably look at just seeing if it can factor, right? So, how am I going to get x to the 4th?
X squared times x squared.
X squared times x squared. I know that both my signs are going to be what?
Negative.
Negative. All right, so let's look at 16. It's like what? 1 and 16, 2 and 8, 4 and 4. I've got to add or subtract to get 8. Add. So which one am I going to use? 4 and 4.
X squared minus 4 is the same.
Now, how many of you would have How many of you would have written x squared minus 4 squared? Now you'd have been done. You'd have been like, dude, I'm done.
But it's not a trinomial.
But
It can be squared.
you gotta double check them. Because they're subtraction, you gotta double check them. Here they were addition, so there was nothing else we could do with it. But with subtraction, and the fact that they're binomials, means they could be difference of squares. So, look at this one. Is this a difference of squares?
Yes.
Yes. So I've got to break this one down into what?
X minus 2 times x minus 2.
X plus 2. Because remember, they got to be opposite so that middle term can drop out. And then what about this one? What about x squared minus 4 here?
Same thing.
This could be the same thing. So it could be x minus 2, x plus 2. Now, guess what I better check?
If it's a
Is that a difference of squares?
No.
No. Is this a difference of squares?
No.
This one? This one? No. So how then am I going to write that right there? All right, Ryan Thompson.
X minus 2 squared and x plus 2 squared.
See, we're really not learning anything new. We're just upping the ante. We're just saying, all right, I'm going to throw it in and see how far I can go. Everybody okay? Questions about this? Questions about why they are what they are? Questions about how did I know that I needed to keep going further and then knew that I could stop? Okay. All right, let's look at some more. You ready? Do number 1 and maybe number 2 all by yourself. See how far you can get. See what you can do. You might surprise yourself. Yes.
except
The 16.
wait, we're gonna get on this one.
We gotta make time. It's a good thing I can live and die by the calendar. All right.
No.
No?
No.
Yes, no, maybe? Okay. If you're stuck, move on to the next one. So work these out. Take a minute to work these two out. Alright, you should be working this out, seeing how far you can get, doing your best, trying your hardest. I got it. And breathe. Okay, thanks. Alright, bye. Okay. Now are we ready? Yeah. All right, perfect. So, let's look. Let's watch me work it out, and let's see how far we got. You ready? What's the first thing that you could do in number 1? Yes, ma'am. Pull a 3 out. All right, so let's pull a 3 out. If I pull a 3 out, I'm left with x squared minus 8x plus 16.
Yes.
Beautiful. Now, 2 days ago, we'd have been like, dude, I'm done.
Well, we're not there.
But now we know more than we knew 2 days ago. Okay? So, this is a trinomial.
Yes.
There are more than one ways to factor a trinomial. So let's just look into it. I know I'm probably going to need 2 binomials. What do I know about my first terms?
Both gonna be after that.
They're both going to be x. What do I know about the inside terms? I mean the signs. They're both going to be subtraction. Now I'm looking at my 16. 1 and 16. 2 and 8. 4 and 4. So I'm going to use what? 4 and 4. Now, before I just jump the gun and write it as x minus 4 squared, because we're so excited we got the same thing, I also have to double check, is this a difference of squares?
No.
Alright, let's talk about what they need to be a difference of squares. Needs to be a binomial. Check. Needs to be subtraction. Check. First and last terms need to be perfect squares.
No.
4's a perfect square, so half a check. What about x? It's not a perfect square. Because if I put x and 2 more parentheses, that's going to get me what?
2x squared.
X squared. And that's not an x squared. Okay? Remember, your x's are going to have a even exponent in order to be a perfect square. So
the way you wrote that bottom one, you don't put x, parentheses, 3, parentheses, x minus 4, and then another 3.
because this whole thing is being multiplied by 3, and if you had to work this out to get back to your answer, you would multiply, you could either multiply this by this first and get 3x minus 12, and then multiply 3x minus 12 times x minus 4 to get this, or you could multiply these first and get this, and then multiply this whole thing by 3. Okay? So, hold on, wait. Am I going to write this as my answer?
No.
Not if I want it to be completely simplified. Instead, I need to write 3
Parentheses x minus 4 squared.
x minus 4 squared.
This is easy.
Now, remember when you're working the other way, that if you see this x minus 4 squared, it doesn't just mean x squared minus 16. It means you've got to write it like this, then do the multiplication to get back to here. Does that make sense? Okay, everybody okay with that? Yes, sir.
I did not do it that way.
How did you do it, sir?
I did it the way that we learned last class.
Okay. So share with me, what was the initial problem again? 3x squared minus 24x plus 48. Okay, so you went ahead and just said, you know what? I'm going to just factor it. I'm going to use 1 and 3. I'm going to use my multiples of 48. What'd you pick? 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8.
It was 12 and 4.
Okay, so you used x and 3x, right? And then you used what?
12 and 4.
12 here with the x?
Yeah.
12 and...
No, it was 4 with the x and then...
Yeah. So 4 would have been here and 12 would have been here, right? Okay, that's doable. Did you stop there?
No.
No? All right, what did you do next?
Well, actually, yeah, that is where I stopped.
Okay, so you can do this, But you can't just stop right there. Because while nothing can come out of this one, 3 can come out of this one. Does that make sense? So you pull this 3 out of this one. And when you pull the 3 out of this one, you get what? X minus 4, right? And then you've got the other x minus 4 that you already had, right? Which is still the same as, so it's fine to do it that way, okay? But once you do it that way, you still got to check each one, see if there's anything you can pull out of it. Does that make sense? Does everybody understand what he did? Does everybody understand why he couldn't have stopped right there? Okay? Everybody good? Okay. Thanks for bringing that up. Good job. And I'm okay with you doing it that way as long as you continue to keep going. Okay? Did you do this one yet?
Yes.
If you haven't, finish it up. If you have, hold tight. We'll be right back to working. So if you haven't finished number 4, take a minute and do number 4. Remember, the worst that's going to happen is you get it wrong. You should be working this. You should be working this. You should not be talking. Remember, simplify as far as you can go. All right, are you ready? I'll give you about 10 more seconds. Okay, let's refocus. Let's look. Anybody got a good suggestion at what you want to do first? Yes, sir.
I made it into binomial.
You made it into 2 binomials. Was there a reason why you couldn't pull anything out?
Because there's no number of friends that have.
Because there's not a greatest monomial factor, right? Okay, so then that means we're going to just make it into 2 binomials. So how am I going to get x to the 4th?
X squared.
X squared, x squared. What are my signs going to be? Minus, a minus, so subtraction, subtraction. I know that because the back one's positive, so that means it's going to be the same. Remember our helpful hints? If C is positive, both binomials take the sign of B. Well, B is negative, so these are both negative. Now, 1 is just 1 and 1, right? But does 1 and 1 add to get 2?
Yes.
Yes, so we're okay. Now, before we jump the gun to write this as x squared minus 1 squared, we have to double check, don't we, Lauren? Yeah. You're Hannah. Sorry, Lauren sits here in my other class. Okay, don't we, Hannah?
Yeah.
Okay, so x squared minus 1, I got to check to see if it's a what? What? Difference of squares. Okay? Is it a binomial? Yes. Is it subtraction? Yes. Is my first term a perfect square?
Yes.
Yes. Is my back term a perfect square?
Yes, ma'am, it is.
Yes, it is. Because what is the square root of 1? 1. I can't do it when 1's an exponent, but I can do it when 1's a whole number. Okay? So this is going to simplify to what? X minus 1, x plus 1. And this is going to simplify to what? X minus 1, x plus 1. So that together, I've got
X
what?
minus 1 squared
X minus 1 squared. X plus 1 squared.
Yes, sir. You got it right.
I don't even know that I want to look, but let's see anyway. How many of you got this one right?
It's not bad. Just look.
It's not that bad. It's not as bad as I thought it was going to be. Let's just be honest about it.
You don't have faith in us.
Well, I do have faith in you, but remember, this is really hard for me to teach because I get it, and so it's hard to break down to you guys. Okay? What up?
I just know to use -1. What'd you -1 from?
Here or down here? Here, both, because remember, when C is positive, both binomials take the sign of B. So C is positive, so that means they're both going to be whatever B is, and B is negative, so boom and boom. Ma'am,
How'd you get the negative and positive number?
because it's a difference of squares, which means one's going to be positive and one's going to be negative to get that middle term to go away. Okay? Remember, I think you told me that earlier. Okay? All right, everybody good? All right, let's see what else we can do today. Maybe. Let's do these 4 and then we'll see how things go. I'm not making any promises,
So after this,
so don't get all hopeful, only to have me crush your hopes and dreams. But at least put forth some effort and then we'll see how it goes. So you should be working these out on your own paper. All by yourself, nice and quiet.
well, you know.
That's why there's 4 of them up there.
Oh, okay.
That would be correct. The first one is incorrect, the second one is correct. Anytime it's a difference of squares, one's going to be positive, one's going to be negative. But that's the only way you can get the middle term, just here. Well, then you better check on to see if it can go any further. But then, yes, if it can, you go like that. All right, now. square of a binomial. Or difference of squares, sorry. Well, what are the criteria for difference of squares? Is it a binomial? Is it subtraction? Is it both terms of perfect square? Sounds like a difference of squares to me. It's into the third, because 3 plus 3 gives you 6, right? Okay. Remember how you get the middle term to fall away. One's going to be a plus, one's going to be a minus. Okay, let's kind of stop wherever you are. Stop with whichever one you're at. Pencils down, eyes here, everybody watching. Let's work our way through these. Chandler, what's the first thing you want to do on number 1?
Pull 3 out.
Pull a 3 out. So I'm going to pull a 3, and when you pulled a 3, what did that leave you with?
Y squared minus 9.
Y squared minus 9. Now, I know if I went back to my list of 5, I've already pulled out a greatest monomial factor, right? And then if I jump down to 3, 4, and 5, 3, 4, and 5 all deal with what?
Factor trinomial.
Trinomials. Do I have a trinomial?
No.
No. So that means the only thing I now have to check for is number 2, which was difference of squares. Because it's the only one that's got a binomial, right? So as my difference of squares, is it a binomial?
Yes.
Yes. Is it subtraction?
Yes.
Yes. Is this a perfect square?
Yes.
Is this a perfect square? Yes. So that means I got to break it in 2. Now, here's where the number 1 place the majority of you are messing up on. When it's a difference of squares, I know that one is going to be positive and one is going to be negative. That is a given no matter what. If it is a difference of squares, one is positive, one is negative. Now,
Doesn't matter which one's negative.
doesn't matter which one's which. One's got to be positive, one's got to be negative. How do I get my y squared? Y and y. How do I get my 9? 3 and 3. Now, because I still have binomials, 3, 4, and 5 are out. Right? But I still have to double check. Do I have to double check this one? Nope, because it's got addition. But I got to double check this one. Is it a binomial? Yeah. Is it subtraction?
Yes.
Is this a perfect square?
No.
Nope, so I'm done. And that is my final answer. Got it right. All right. Now, let's look again. You ready? Let's look at number 2. You should start by saying, is there anything I can pull out of both of them? No. Then you should say to yourself, okay, it's a binomial, so that immediately eliminates 3, 4, and 5. Right? Because 3, 4, and 5 have to be trinomials. So now, I need to look to see, okay, is this a binomial? Yes. Is it subtraction? Yes. Is this a perfect square?
Yes.
Is this a perfect square?
Yes.
Yes. Boys, knock it off. When it's a difference of squares, what do you immediately know about your signs?
One has to be addition and one has to be
One's
subtraction.
plus, one's minus. How do I get x to the 4th?
X squared minus squared.
X squared, x squared. Because remember, you're adding the exponents to get the 4th. So x squared, x squared. What is the square root of 81?
9.
9. 9, and 9. Now, because these are binomials, I need to check for difference of squares, right? Is this one going to be a difference of squares? No. So I know it's going to be x squared plus 9. But is this one a difference of squares? Yes. Is it a binomial? Is it subtraction? Is this a perfect square? Is this a perfect square? So, because it's going to be a difference of squares, one's positive, one's negative. How do I get x squared? X and x. How do I get 9? 3 and 3. One last time. This one's positive and this one's positive, so I don't have to check it. This one I've got to check. Is it a binomial?
Yes.
Is it a subtraction? Is this a perfect square? No. So I'm done. Anybody get that right? Like, I don't even think I want to look. How many of you, okay, let's rewind. How many of you got the first one right? Okay, good. See, that makes me feel better. What happened on the second one? Did you forget? How many of you, let me rephrase. How many of you forgot to check this one? And you stopped right there. How many of you stopped right there? Okay? You've got to be careful. How many of you split this one too? Do you understand why you can't split this one too? Somebody tell me why you can't split this one too.
There's no subtraction.
There's not a subtraction. Difference of squares does mean subtraction. There is no sum of squares. No, there's not. Okay? Can you do 3? Have you already done 3?
Yes, ma'am.
All right, let's look. What do you want to do for 3?
What?
Yes, sir.
Greatest monomial factor.
Greatest monomial factor. What do you want that to be?
I want that to be 5.
A 5. When you pull out your 5, what are you left with?
M to the 6
M to the 6
minus 4.
minus 4. All right?
Yes.
Now, because this is a binomial, I can automatically eliminate 3, 4, and 5. Because those are trinomials, right? So, is it a binomial? Is it subtraction?
Yes.
Is this a perfect square?
Yes.
Is this a perfect square?
Yes.
How do I tell when my variables are perfect squares? If the exponent is even. Because remember, you have to be able to add the same number to get your exponents. Okay? So, 5. And I know it's a difference of squares. So that one's going to be what?
Addition.
Positive. One's going to be negative. M to the 6 becomes what? M to the 3rd. M to the 3rd. 4 becomes what? 2 and 2. Do I have to check this one?
No.
Why not? It's positive. Do I have to check this one? Yes. It's a binomial and it's subtraction. Is M to the 3rd a perfect square?
No.
No. So that means I'm done. Anybody get that right?
Me.
How many of you got it right and thought you were wrong? Uh-huh. Okay. All right, you ready?
Oh, actually, this is a very
You ready? What, Maggie Clark, do you want to do first?
We pull out 5.
Pull out a 5. Now, when I pull out a 5, what are you left with, kiddo?
5 to 4 minus 16.
Minus who?
16.
16. I thought you said 60. Okay. Now, because this is a binomial, what do I automatically know?
It's going to be. You guys check it.
3, 4, and 5 are out. Because those are all trinomials. Okay? So I have to look to see if it's a difference of squares. Is it a binomial? Yes. Is it subtraction? Yes. Is this a perfect square? Is this a perfect square? Okay. And when it's a difference of squares, what do I know?
Plus and the other's negative.
One's going to be positive, one's going to be negative. Y to the fourth gets me what? Y squared, y squared. 16 gets me what? 4 and 4. Am I done? No. Okay. Is my 5 okay?
Yes.
Is my y squared plus 4 okay?
Yes.
Do I have to check my y squared minus 4?
Yes.
Yes. What am I checking it for?
The perfect square.
The difference of squares. Is it a binomial?
Yes.
Is it subtraction?
Yes.
Is the first one a perfect square?
Yes.
Is the last one a perfect square?
Yes.
Oh man. All right, so here we go. Everything prior to this stays the same. I know that one's going to be what? Positive. One's going to be negative. How do I get y squared? Y and y. How do I get 4? 2 and 2. Is my 5 okay?
Yes.
Is my y squared plus 4 okay?
Yes.
Was my y plus 2 okay?
Yes.
I got to check my y minus 2. Is it a binomial?
Yes.
Is it a subtraction?
Yes.
Is this a perfect square? No. So I'm to the point
No return.
of being done.
Oh, done?
How many of you got that as your final answer for that one? Oh, no way. Yay. Does this make any sense at all?
Yeah.
Okay. Are we okay?
Yeah.
Are we getting better? Are you feeling better about it than you did initially?
Yes.
What is your question, sir?
If I'm being honest, what we started with on number 4
Looks way simpler, doesn't it? Yeah, it does.
Can we do one more time?
Okay.
Please, please. I'm ready. It's too easy.
What if we do these two?
No.
Okay.
What if we do 1? We have to
Okay, let me pick the one I want you to do.
Two.
Wait, can you help us do one and then we do one?
Sure, that'll work. Okay, that's a good compromise. Okay,
What are we doing?
zip it. Write the first one down. We'll do it together.
Oh my goodness. You made this complicated.
Hey, I did. If you got a problem with it,
No, ma'am,
there's the door.
it's a great compromise.
Okay,
Where should we go
just
after?
call me Henry Clay.
Where should we go
Okay.
after?
Who is Henry Clay?
The great compromiser.
We just worried about it on the.
I can't even function with you people. Okay.
We took a picture.
Okay. And the fact that Cole was with us when we took that picture in front of it concerns me immensely.
It's Henry Clay.
Okay.
They were everywhere.
Yes, it was one of the 5,000 pictures we took. Okay, are you ready? What do you want to do for number 1?
We don't know.
Yes.
Can you take a Y out?
Let's take a y out. All right? So if I take a y out, I'm left with y squared minus 5a plus 6a squared.
Wait, isn't there a Y?
5ay, thank you. Okay. Okay. Now, yes ma'am. Can I take an a out? Well, I've got one here. I've got one here. I don't have one here, so I can't take an a out. All right. Shh. Now, I've taken out my greatest monomial factor. Do I have to worry about difference of squares?
No.
No. But I do need to check and see if I can factor it as a trinomial, right? Oh, I don't know what just happened there.
Nice block.
All right, let's try again.
Yeah.
Oh, yeah.
All right. So y. How do I get my y squared?
Y times Y.
Y times y. What do I know about my symbols? One's no, wait, what? They're both negative because this one's positive. Okay, just kidding. All right, good. How do I get 6? 1 and 6? 2 and 3. Do I have to add or subtract to get 5? I have to add 2 and 3. But this time the 2 and the 3 has to also have a what? An A. So 2A, 3A.
What about the Y behind that 5?
Yeah.
Okay, hang on.
Here's SOL now.
Now, these are binomials, so that means I only have to check to see if they're difference of squares, right? Binomial, subtraction, perfect square? No. Binomial, subtraction, perfect square? No. Now, you're worried about, is this done? Watch what happens when I multiply here. Y times Y gets me what?
Y squared.
Y squared. Y times negative 3A gets me what?
Oh, she's got you.
Okay.
Negative 2A times Y is what? And then negative 2A minus, or times negative 3A is what? See where that negative 5Y or AY comes from? Okay? So we're done.
Is that homework talking?
Okay? That's the one we did together.
Oh, that was the conference together.
Do this one by yourself. Go. Go. Less talking, as in no talking. Pencils on your paper, working. No talking. Go. Sister, I'm going to sit there and not do anything. You know why? Because you haven't been trying the whole time. You've been sitting there sulking because you didn't know how to do it. Because 5 minutes left in a class is not the time to say, hey, I can't see that. All right, are you ready?
Yeah.
Okay. What do you want to do first, my dear?
X squared. No.
Pull out an x squared?
No, like parentheses.
Okay, so like binomial it. Okay. How do I get x to the fourth?
X squared times X
X squared times x squared. What do I know about my signs?
One's addition, one's subtraction.
One's addition and one is subtraction. How do I get my 12? 1 and 12, 2 and 6, 3 and 4. Maggie, which one do you want to use?
4 and 3.
Because you got to subtract to get 1.
Yeah.
Which one needs to be with the positive?
4.
The 3.
Oh, I got that.
Which one needs to be with the negative? The 4, because I need the larger one to be negative.
Oh,
Okay?